1. So this is lecture number 6, 15 to 2021. So I'm going to give you as a tutorial problem now. Expect you who is going to answer first, and I'll give some 5 minutes time. All right. I'm going to expect that you are going to apply what I have taught in the last problem and find the same. So look at this configuration of the beam. The beam is bent frame kind of thing. It's a one member, rigid member, which is of L shape, and that has been supported appropriately and defined with this coordinate system. So look at that. I have a Cartesian coordinate system. This is my x-axis. This is y-axis, and I have here z-axis. So this is right-hand coordinate system. If I stretch my 3 fingers of the right hand, index, thumb, and the middle finger. So middle finger pointing x-axis, y-z represent positive axis respectively by middle finger and the thumb. So this is what is right-hand coordinate system, and this system now I'm going to use it for to define a member, horizontal member. So that spread from point A comes like this in the same plane, and it goes again parallel to Z axis into this. So if you see, this is a member that goes further here, and that is supported appropriately here, maybe a hinge here, and then it is not sufficient. There is a hook here. Through that hook there is a cable that is supporting it. So there is a cable goes one from here to here, this plane, and the same cable goes around here to here. So now the position of this cable are given from this y-axis. This is at a distance, say at 280 mm. This is at 280 mm. And this is positioned, I have not drawn this to the scale, position along this at a distance 740 mm. 740 mm. And the length of this member, so let's name for convenience, this is A, this point is B, this point is C, where the bend is there, and this point is D. So I have this length of AB and BC is 400 mm respectively. All are in mm. Right? And the point here, this point is point H. This point is point G. And this point H from here, it's a perpendicular distance from this XZ plane, is 600 mm. Right? So I have here the diagonal, which is AD line. So my question is this AD line and this portion of the string BH, is it intersecting or not intersecting? Can anyone answer? In the picture, as if it is intersecting here, but it is not so. It is in this plane XZ. AD is a diagonal or no of this rectangle, which is on this. Whereas this cable goes from H and through point B to G, which is in space. So now the tension in this cable is given by the value. So there is a force that is this tension. So this tension is given by 1125 Newton. 1125 Newton. All right. So now the question what is asked here is, what is the shortest distance between this BH and AD? Determine when the shortest distance between the skew lines AD and BH. That's the question. So can you just find out? So you are also given this distance here. It's missing CD measured from here is 600 mm. Yeah. So can you just find out now what is the shortest distance between them using the principle what I have taught in the last class? Are you comfortable? Can you solve this problem? Or you have any doubt? Or you need any clue or steps involved? Arun. Is Arun present? Chandra Aditya?
Yes, sir.
Yeah, so can you solve this problem? You understood how do you solve this problem?
So first we have to find the coordinates of the line.
Correct. So what is the idea? What is the idea? Okay, that's all interior detailed steps. What is the idea to go about solving this problem? I have a force on one line, I have an axis AD, right? So if I am asked to find out shortest distance between two lines, I require on one line a force. So force is there on this BH, right? Chandraditya?
So should we find the perpendicular distance, sir?
So yeah, that is it. The shortest distance in the perpendicular distance between two lines. So how do you find out that? So for that I should have a force vector or any other known vector along a line. So in this case of our basic mechanics, statics that we study, we see the tension in this cable given, so that force I am taking. So that is on a BH on one line and AD as my axis. So if I find moment of this about AD, right, about AD line and its magnitude, then I can apply my scalar definition of moment of a force about a point. So what I have to do, I have to know what is this force component, one parallel to AD, another one perpendicular to AD. So perpendicular to AD into shortest distance, that is moment arm, is what is equal to magnitude of this moment produced by this force about line AD. So that's what I have taught in the previous problem. In there, what is the difference from there? The line was OX itself, OY itself. So only J unit vector. But here you have, instead of axis OY, you have axis now AD. So find the moment of this force about AD, its magnitude, and then resolve this force one parallel to AD, perpendicular to AD. The perpendicular component into shortest distance is what is the magnitude of moment about AD, and that solves for D. That's all. This is a step that I expect that you would have explained. You understood that, but you started solving the problem. So you said first write the coordinates. All correct now. So why do you have to write the coordinates? Because you require position vector for taking moment of this force about the axis AD. Right? So what are the possible means that I can find the moment of this about AD? So moment of the force about line AD for the force FBH. That's what I write it. So the statement by these letters. So that's going to be equal to moment of the force FBH about one of the point either A or D. So let me take A dot unit vector of the axis. Unit vector of axis UAD. So this is going to be what? It's a cross product. MA moment of force about point A will be about this. So this is my moment center. My moment arm, or there are two. One is RAB, another one is RDB. So I can also have this because A and D are the points on the line. So I'm going to use this position vector RAB cross FBH. So this moment would be RAB cross FBH dot UAD. So see, now it's nice scalar box product. So I have to write my position vector, position of B with respect to A, and my force vector in line BH from B towards H, and the unit vector UAD. So this all require positions of point A, B, D, and H. So let me write those points for interest. So what is A point? If this is my point O, what is my coordinate A? So it is along Z axis. So X is 0, Y is 0, Z value 600 mm. So I'll write that as 0.6 meters. What is my position vector? Position B, this point. So it is now on this X Z plane. So Y is 0. So what is my X? X along this direction 400. So 0.4, 0, comma. What is my Z? Z is 0.6, right? Because this distance. And now what is the position H or D? Next is D. So this point D is on x-axis at a distance 800 mm. So it is 0.8. Since it is on x-axis 0, 0, rest of the coordinate. And what is point H? Point H is here in xy plane. So Z 0. So what is my X? What is my X? X is not given. Oh, just a minute, let me just check. That is 700. So consider this distance as 700. This distance as 700 mm. So that's going to be X is 0.7, comma, Y is 0.6, comma 0. So I have written down the coordinates required. Any doubt in this process, what I have done? It's clear. So why did I choose only these points? Look at here RAB and BH and AD. So these are the 4 points required now here. So I can find out now what is my RAB. So RAB vector is going to be B minus A. So B minus A is 0.4 I 0. So 0. So 0.4 I is what is FAB, RAB. And what is my U or FBH. So that's going to be 1125 times UBH. So how do I get that? 1125 times UBH is H minus B. So H minus B is 0.7 minus 0.4 is 0.3 I. 0.6 minus 0 plus 0.6 J. 0 minus this minus 0.6 K is what is my position vector divided by just a minute, divided by its modulus. That's going to be 0.3 square plus 0.6 square plus 0.6 square. Right? So this is my force vector. And what is my third vector? UAD. So UAD unit vector is RAD by modulus of RAD. So that's going to be D minus A. So D is this. So 0.8 minus 0 is 0.8I 0 minus 0.6J 6K divided by the root of 0.8 square plus 0.6 square. That's my UAD. So just to calculate this and substitute them in this and find out what is the modulus of this, because this is a box product. So you get a scalar value, and this scalar value can be used with the scalar definition of moment of a force about a point. So when I look at the perpendicular component of this and parallel component of this, one with the perpendicular component to the axis AD would cause the moment with this value, and I can find out the shortest distance. So can you just find now and tell me this value? I'm not going to work out, I'm going to make you as you are working parallelly substituting this. So what is this? It's going to be a determinant. It's going to be a determinant. First row is RAB, I have it here, 0.40, 0. So if I had to work out this determinant, right? So what is that? It is 0.40, 0. And cross, next one is force vector. So take this and this radical out and put this alone inside, second row. And then third one is take this radical out and put this here. So second row will be third row will be 0.8, 0 minus 0.6. And here I have, and I have to take this out. So this radical sign out, whatever is there. And similarly for the force vector also, I have to take 1, 1, 2, 5 and the corresponding radical out. And I would write here inside 0.3, 0.6 minus 0.6. So if I carry out this, these two happens to be 0, so it's simple. So 0.4 into this minus this would give you straight away the determinant value. Multiply with that, I will have what is this magnitude. So can you just work out and tell me the magnitude? Let me see who is going to answer first. I'll wait for a minute. Anyone? Harsh Hosamani, Manta Ravishankar.
Yes, sir.
Yeah, are you solving?
Yes, sir. I'm doing, sir. 1 second. I'll tell you the answer.
Yeah.
Yes, sir. I'm Harsh. You called out my name.
Yeah, what's the answer?
Yes, sir. I'm doing.
Yeah. Let me see who is going to answer first. So I have explained you the procedure, also written down complete step. You have to just work out the determinant and tell me. Aravind K.
So doing, sir. I'm doing, sir.
Yes, sir. Doing.
Aravind E and Aravind K. There are two people. Dhanush, Kishan, Venkat. Hi Sam.
Yes, sir, Venkat, doing, sir.
Doing,
Yeah.
sir. Doing, sir.
Good. Sahil Chaudhary. Sahil. Sanjay Anto.
Sir, doing it, sir.
Okay, good. See, because it's a virtual class, I do not know. You are not put on your video as well. So just to see who are all present, I'm calling the names. Shubham Mittal.
Minus 50.
Yes, sir. Here, sir. Doing, sir.
Good, good.
60, sir, answer.
Sri Harsha. Yeah, someone solved that, prompting the answer. Rohish Vishwa was answering, I think so. Helen Jerry. There are 41 students out of 47 in the class. Okay. Anybody? If not, shall I proceed with writing the answer? Because I require to finish this and go to the next lecture. Or you want a minute?
Sir, 1 minute, sir.
Yeah.
Sir, minus 750.
Minus?
Just a minute, sir.
Yeah.
Is it minus 750, sir?
No. Minus correct, but it's not 750. So if I work out this, it is 1125 divided by the root of 0.3 square plus 0.6 square plus 0.6 square, again under root of 0.8 square plus 0.6 square, right? These two radical. And in numerator, I will have what? 0.4, 0.4 into this minus this. So that's going to be minus 0.36 minus 0. So if I work out this, what is that I get? It's minus. Anybody has solved? 180 Newton meter. Just check. Are you getting this? Okay, now what is the second step? This is first step. So second step is to write this modulus, what you have got for this about dH for the force F, A, FA or FBH, right? FBH. Moment about the line. What was the line? So just a minute. What is the line? That's AD. Moment about AD. So AD. This is not DH. AD. AD. About AD, what is the moment by this force? FBH. That's what we have found out now. That's what we have found out now. This modulus value. So this modulus value is going to be now equal to FBH, its perpendicular component to line AD, right? Into D, moment arm. That's all. So this is moment arm, or you can say shortest distance. So I need to find out now what is this component. So how do I find out that? How will I find out that? What is my FBH perpendicular to AD? That would be FBH modulus square minus FBH parallel to AD component square. So finding FBH parallel to AD is easier instead of finding out this. So I will get this by this. So these two numbers to put, now I will find out what is modulus of FBH parallel to AD. So that's simply a dot product FBH vector dot UAD vector. So FBH vector is this. So 1, 1, 2, 5 divided by this radical dot UAD. UAD is this. So I have to put that here. 0.8I minus 0.6K divided by that radical. 0.8 square plus 0.6 square. So this dot product would give me now. So here this what is there in this is this radical. Whatever is there, 0.3 square plus 0.6 square plus 0.6 square. So this entire thing would give me what is this component? Magnitude. It's a scalar product. So what is the value that you get? Here is what is the value? Can anyone answer, solve and tell me? So answer this. Get the answer. I leave it to you as homework. You have to work out. Put the value over here. So that I will have this component, right? And take that value from here into D is what is this magnitude? Minus 180. Therefore, D would be minus 180 divided by this bracket. So that would give me what is the D value. So that value would be equal to 215 mm. I'll get this value here 0.215 meters. So that's going to be 215 mm. So cross check this answers.
Sir, can you scroll down a bit?
Yeah.
So,
So
no, sir. I mean, like,
yeah.
whatever you're writing, it's not visible on the screen. So, like, if you could scroll up a bit, not down.
Yeah, that is all I have written till here. 215 mm that you are able to see. Right? Are you? The final answer is the shortest distance is 215 mm. Are you able to see the screen?
Yes, sir. Yes, sir.
Yeah. So there are two steps here. One is finding out moment of the force. See, two lines are in skew in space. Shortest distance to get, and one line you have a force, other line acts as an axis. So find the moment of this force about this axis. You know that scalar box product. You have found that here. That's this value. That is this value. This is first step one. So once you have that, then that magnitude is obtained how? By the force FAB, but it's perpendicular component to the axis, not by the parallel component. That's very clear. So the perpendicular component of the force to get, I just use this. I know the magnitude of the given force. I can find the parallel component force by simply taking its dot product, the force dot product with the axis. That is here. FBH dot UAD. UAD is the axis. So what is the component of this force parallel to this line axis is that I have to do a dot product with the unit vector of the line. So I get this component. I plug that value here. I get what is the magnitude of the perpendicular component, and that perpendicular component force into moment arm, that is the shortest distance, is what is the found out moment by the force about that axis. That solves for the shortest distance. That's all. So here whatever is missing you work out, fill, and finally you should have this answer. So this is very important application of moment of a force about a line about an axis. So